All right, today we're going to dive deep, and I mean deep, into the prehistoric oceans to tackle a puzzle that left scientists scratching their heads for over 100 years. We're talking about Helicoprion, a creature with a jaw so bizarre it looks like something out of a sci-fi movie.
For the longest time, this is pretty much all we had to go on. Just this strange spiral-shaped fossil made of teeth. Now just imagine for a second you're a paleontologist. You dig this up. What are you even supposed to think? It is unlike anything else in the fossil record. A total scientific enigma.
And that, of course, led to the big question that stumped everybody. Where in the world does a buzzsaw of teeth even fit on an animal? Was it on its nose, maybe its tail like some kind of weapon, a fin on its back for defense? For decades, the theories were just all over the place because, look at it. The fossil itself is just that weird. Yeah, the comparison to a circular saw was immediate. You really can't avoid it. It just looks like this powerful mechanical tool. But what's so wild is that this thing was forged entirely by nature. And as if it wasn't strange enough, there's another layer of mystery here. The spiral isn't just a random coil of teeth. No, it follows the golden ratio, that famous mathematical pattern you see everywhere, from the shape of galaxies to seashells. Finding it here was a huge clue that this wasn't some freak of nature, but something highly evolved and incredibly precise.
So, to really get a handle on this creature, we first got to understand the world it lived in. Let's take a trip way back in time. We are heading to the Lower Permian period. We're talking 275 million years ago. Now, to be clear, this is an ancient time, long before the first dinosaurs ever took a step.
Back then, the planet looked completely different from today. All the land was basically smashed together into one giant supercontinent we call Pangaea, and that was surrounded by a single massive global ocean, Panthalassa. And it was in the coastal waters of this primeval world that Helicoprion ruled as a top predator. And when I say top predator, I am not kidding. This creature was enormous. Some species could grow up to 12 meters long. And here's some perspective for you. At 12 meters, a big Helicoprion was literally double the length of a modern great white shark. It was an absolute giant of its time, no question. But, okay, if it was that big, that just brings us right back to the fossil puzzle. Why was a tooth whorl pretty much the only part of it that we could ever find?
You know, out of all the fossils we found around the world, maybe 150 of them, almost all are just these spirals. No skulls, no spines, no fins, just teeth. Well, the answer actually lies in the biology of the animal itself.
See, just like modern sharks, Helicoprion's entire skeleton was made of cartilage, not bone. Now, cartilage is great when you're alive. It's light, it's flexible, but it breaks down really fast after death. It just doesn't fossilize well. So the only truly hard, durable parts of its body were its teeth. And that's why they're the only things that survived for us to find millions of years later. So for decades, this mystery just sat there, unsolved. But then, in the 21st century, technology finally gave us the key to crack the case of the spiral jaw. So, after more than a century of wild speculation, starting with that first discovery way back in 1899, the big breakthrough finally came in 2013. A team at the University of Idaho got their hands on some of the best preserved fossils and used high-resolution 3D scanning to digitally rebuild the creature's head. And what those scans showed? Well, it changed everything. The spiral wasn't some weird weapon on the outside of its body at all. It was tucked neatly inside its mouth. It was the creature's entire lower jaw. All those crazy theories were wrong. The saw was its smile. So how did this even happen? Well, unlike modern sharks that are constantly shedding and replacing their teeth, Helicoprion never lost a single one, not one. As new, bigger teeth grew in at the back, they just pushed the older, smaller teeth forward and down into the jaw, creating this incredible, lifelong conveyor belt of teeth that spiraled inward. And while Helicoprion was a global hunter, found everywhere from Russia's Ural Mountains to Australia, this chart right here shows you why that Idaho team was so important. More than half of all the fossils we know about have been found in the phosphate mines of Idaho. They had the key specimens needed to finally crack this case wide open.
Okay, so now that we know where the jaw went, we can finally figure out how it worked. And it turns out this incredibly strange design made Helicoprion a brutally effective hunter.
Think about a great white shark. It has a pretty impressive 60-degree jaw gape. But Helicoprion? It could open its mouth to a full 90 degrees. I mean, that gave it an absolutely enormous bite.
And its attack style was just a masterpiece of mechanical efficiency. The jaws would swing open super wide, the backward-pointing teeth would snag soft-bodied prey like squid, and then, as the jaw closed, the whole spiral would rotate backward, literally pulling and rolling the meal deep down its throat. It was basically a capture-without-release system. Once it got you, you weren't getting away.
So in the end, this wasn't some clumsy, awkward evolutionary experiment. It was a masterpiece. You've got a conveyor belt of up to 150 teeth that are always sharp, a wider bite than any shark alive today, and this ruthlessly efficient feeding system. All of that made Helicoprion a perfectly adapted predator.
And that success is what makes its ultimate fate all the more mysterious. I mean, if it was so perfectly designed for its world, where did it go?
The author of our source material, Aaronne Colagrossi, frames this question perfectly. It really is the final enigma of Helicoprion. Here you have this creature that was a pinnacle of predatory evolution for millions and millions of years. And then, poof, it vanished.
And this really leaves us with a final, massive question to think about. The story of Helicoprion shows us that perfection is always relative. Its jaw was perfect for hunting the soft-bodied prey of the Permian oceans, but when the Permian period ended in the single largest mass extinction in Earth's history, that entire world disappeared. Its hyperspecialization, the very thing that made it so successful, may have become its fatal flaw. So what happens when a perfect key no longer fits the lock?